Hey everybody, it's Brian Fleischman, Shorewood High School, AP Computer Science. Today I'm going to be talking about the array methods and for each loop assignment. If you haven't tried this assignment, you can find a link to it in the video details and you can give it a try and then come back and see the solutions that I'm going to provide here. If you don't like my solutions and you think you have a better one, comment it. I would love to see that. I often don't come up with the best solutions. So yeah, pause the video now, go try the assignment, come back. If you're in my class, I'm going to go over these solutions right now. So here's a challenge. What's the output of this program? I've copied this into my Eclipse right here. Let me see if I can back up a little bit. I altered it a little bit. There you go. So here's the code. Let's kind of trace it a little bit. In the main method, we declare and initialize money as an array of 4 elements. There they are. We call this method double my money, with money as a parameter. It gets passed in. And then we use a for each loop to print every element. All right? So let's talk real quick about something really important. Money itself is not an array. Money is essentially an address for where to find the array. This is really different than regular old ints, okay? Like if I make an int like called x and it's 10, x really is the value 10, right? That variable inside that box right there is the number 10. It's different for an int array and all other objects of that type. Money is not big enough to hold the entire array. Essentially what it has to do is make a little address card for where to find this array so it can go to it when it needs it, okay? This is the difference between a primitive semantic here, right? We got this like primitive variable like an int. It can hold the entire thing right there. 10 is small enough to fit in this variable. An int array, on the other hand, is too big, no matter how, even if it's only one element. An array is too big to fit in the variable, so we resort to making a little address card, and I actually printed that earlier. This is what happens when you print the variable money. It's not an array, it's essentially like an address for where to find the array. A little bit oversimplified, but hopefully that kind of makes sense. Okay, let's remember that, okay? So, here's money, right? And double my money passes this parameter money up here. So M essentially gets a little copy of this address. So I could write a little comment up here. M is essentially this same thing right here. M gets this. It's like, fairly, it's just like a little bit of an oversimplified version of what I'm talking about. So right now there's an M variable that's pointing to this array. And there's also the money variable that's pointing to this array. So it's two different variables that have the same sort of address, right? May seem like I'm kind of like getting into the nitty gritty, but this concept is super duper important. Okay, I cannot stress that enough. For the AP test, this is huge. Okay, there's a variable called money that's pointing to this array. There's a variable up here called M that's also pointing to this array. It has multiple variables pointing to it. Okay, all right, let's look. So let's go through this. M.length. The length of this array is 4, so we're just going to go through every element in the array. And each element is multiplied by 2. Now notice, so this element times equals 2 is 14. This is 6. This is 2200. And this is 98, right? Now notice, that was just M, right? M's array changed to this. But in doing so, that's the same array that money was pointing to. Right? So essentially, the array that money is referring to down here changed as well. We're not used to seeing this from ints, for example, right? Ints, for example, don't do that. But when you pass arrays into methods, the changes that occur inside the other method are kind of changes everywhere, right? Because the variables are really just addresses to the same array, right? It's not the same for primitive ints, and we've seen that before in my class, but I'm not sure about yours. Yeah, try this with just a regular old int, and it won't do the same thing. All right, so now that we know that the array is doubled at each element, I use the for each loop to get through this. Now, just in case you need a little descriptor of what a for each loop does, here's how it works. You need a little temporary variable that you can store each of these values in. Right? So 14 will be x, then 6 will be x, then 2200 will be x. Each of those are ints, so you need to declare them as ints. And then it doesn't really matter the variable name you give it. You could have called it like, Abernathy if you wanted to, whatever you want. But over here, need to have the variable that points to the array that you're talking about. So for every int in money, essentially, I'm going to print that, right? So hopefully I get 14,6, 2,298. Let's run it. Not a surprise. There it goes down there. Okay, that's number one. If you got anything out of number one, it's that. Variables that store int arrays, or any array for that matter, aren't actually holding the array. They're holding some sort of address for where to find the array. And when you pass those parameters, this other parameter just gets a copy of that same address. So any changes that occur in another method are changes back in the main method as well. The array is the same array. It's changed. Okay? All right, let's move on to number two. Number 1b, excuse me. Okay, here we go. Let's get tricky with arrays. What elements does the array numbers contain after the following code is executed? Yeah. Okay, I've seen stuff like this before. By the way, if you ever find yourself doing what I'm about to do in your own code, I don't think you should. Right? Real world code doesn't often do stuff like this. Right? That's super rare. And if you do it, maybe you should think about how you can make it simpler. Anyway, this is just a test for you as how well do you understand indexing in arrays. It's not necessarily a real world application, not going to lie. So let's model this array up here. All right? On line number 7, int array numbers is declared as a new int array of size 8. So check this out. At that moment of creation, Java creates this. It can't have an array that just has blank stuff in there. It really does need all of the elements filled. So if you don't decide right away, it'll go, I guess I'll fill it with zeros. This is called the default value, right? Makes sense. 0 seems like a reasonable default value. Okay, so it does fill this up with zeros. It's not like it's blank. There are zeros in there. So numbers at 1 becomes 4. That's this spot. Remember, 1 is here, not there. 2 becomes 99. 3 becomes 2. Int x, so I'm going to make a little variable up here. X is going to be the value, whatever is numbers at 1. So that'll be 4, all right? Numbers at x, really what I'm talking about down here then, is numbers at position 4, right? Because that's what numbers is, right? Numbers at position 4 should become 44. So 0, 1, 2, 3, 4 becomes 44, right? And numbers at 7. So numbers at 7 is just 0, isn't it? So really I'm just talking about numbers. Oops. So I have to look at this. What is numbers at 7, right? Numbers at 7, 0, 1, 2, 3, 4, 5, 6. Numbers at 7 is just 0. So I can rewrite this line with all this blue stuff replaced with the number 0. So this is just telling me to replace numbers at 0 with 11. So here it is. That's the final array. 11, 4, 99, 2, 44, 0, 0, and 0. I should get that if I print this. Let's see. In case you forgot how to print an array, that's how. Arrays.toString, right? And if that gives you a red underline, you need to import the package. Control-Shift-O or Command-Shift-O, depending on your Mac or PC allegiance here. Here we go. Let's see how much a fool I've made of myself. 11, 4, 99, 2, 44, 0, 0, 0, of course. There you go. Right? So if I were you, I would be doing this kind of stuff, these notes, on like a scratch paper or even like in a notebook. You shouldn't like litter this stuff throughout your code. I'm just doing this because I can't like do it in a notebook for you guys. So that's number 2. Sorry, that was 1B. 1C. What does the array contain after the following code is executed? Let's see. All right, so I'm going to copy paste. I'm going to tab this stuff in. I'm a stickler for that kind of stuff. Okay. Yeah, make sure if you're out there and if your teacher isn't teaching you about indentation and curly brackets and the placement of them, look how professional programmers do it. Like people don't just like willy-nilly have spaces and random indentation in their code. Make it look good, okay? It's the same as the rule of mountaineering. The first rule of mountaineering is you have to look good. The first rule of code is it has to look good, okay? Let's move on. Int array data. We got a new int array of size 8. So it's the same thing we just did before. I had like this array of zeros. 1, 2, 3, 4, something like that. Okay, a bunch of zeros. All right, there's my array. That's data. Well, data points to that, right? Then it tells me that data at position 0 should be 3, so I can do that. Data at 7 becomes negative 18. That's this one. I know because it's size 8. The last index will be 7. Data at 4 will be 5. 0, 1, 2, 3, 4. This will be 5. Data at 1 becomes data at 0, so it duplicates that. So data at 1 duplicates this value, which is 3, so it'll also be 3. Then I have this little variable, x equals data at 4. So what is data at 4? Data at 4 is 0, 1, 2, 3. Oh yeah, I just filled it with the number 5 a second ago. Then it says data at 4, you should become 6. Now data at x, which is data at 5, right? That's data at 5 because look, x is 5. Is data at 0. Data at 0 is just 3. And data at 1 is 3. So really it's just telling me to put data at 5 should become 3 times 3, which is 9. 0, 1, 2, 3, 4, 5. There you go. Right there. So I think it's 3300,690, negative 18. But I don't know. Let's find out. Arrays dot to string data. I know there's like a certain subset of the watching audience right now that are data kind of people. I'm a data kind of person. Don't know why. 3300,690, negative 18. Perfection. All right. So hopefully these little notes kind of help you. Do these in your notebook. Do them on a scratch pad. Whatever you got to do. Don't try to galaxy brain it too much. Right? Write it down. I wouldn't do it without writing it down. Let's check it out. 1D. Whenever you want to examine each value in an array, you can use a for each loop. Yeah, we saw that in problem number 1. Interesting that the worksheet tells us about for each loops after we've already seen them, okay? You should only use a for each loop when you want to examine a value in the array. If you want to access the array to change the values, a for each loop will not work. This is true. I can show you why in a second if we have time. Here's the structure of the for each loop. Yep, we already seen one before. Type name, right? So int x within money. We already did this, right? And then you do stuff in here. So for each loops are really great at accessing every element of your array. The key word is accessing every element. You can't modify your array with a for each loop unless, of course, you make it seem more like a regular for loop, in which case a regular for loop would be appropriate. Using a for each loop, write a piece of code that examines an array of integers and reports the maximum value in the array. All right, so here's the deal. That's the problem for 1D? Write a max value. Okay, I can do that. Let's do it. We can even test it with this array. So I'm actually not even going to delete this code. I'm just going to write some new code. So if it's going to return a max value, I'll just do public static int. Max value within some int array, right? Very common in programming when you pass an array as a parameter generically. ARR is what I see a lot, so that stands for array. So here's what I'm going to do. I'm going to assume that it's a little bit like dating. Think of it this way. The first girl you see or first guy you see, whatever you're into, is always the best one until you see something better, right? So like if you're going to date like 10 people in a row, after number 1, you're like, that's the best one I've ever seen. Of course, because it's the only one you've seen. And then you later compare the subsequent ones to the best one that you've ever seen. So here's what we're going to do. Biggest number, the max, we're going to assume it's the first element in the array until we find something better. Right? Now, of course, we'll probably find something better. This is just, there has to be somebody on the pedestal first in order to compare everything else to, right? So I can now compare every integer, every number within the array like this, right? It doesn't matter what I call this, okay? This matters. This is the array that I need to get through. It's the array that I pass in, right? This right here is just something that I'll refer to each value as within here. I could have called this anything I wanted, right? All right, so here's what I want to know. If the number, let's like take a look at this array, if I could copy it. All right, so right now maximum is 3. So I'm going to write that right here. So it says it assumes that the maximum is 3, but until I find something better. Basically what I want to do is if num, so num, remember each of these numbers will take turns being num, right, one at a time. If that number that I'm looking at the time happens to be greater than what I thought was the max, well, then I have a new winner. So that will happen right here, won't it, for the first time? 6 will be num, and 6 will be greater than 3, which was the previous max. So what should I do? Max should then be replaced with 6, right? So if the number I'm looking at is greater than max, well, then I have the wrong max. Max, you need to be num, right? And then, so at that point, 6 would be the winner. And then it would check the next one, and then 9 would be like, hold on a minute, I'm greater than you. And the max like, hold on, okay, I'll be 9. And then we'll check out for the rest of it, and then 9 should be returned at the end of this. Return max. Cool thing about this algorithm is that it works for any size array, except for an empty array. Except for an empty array. An empty array, right? It's possible to have an array with no values in it. It's possible, right? It's true. This would break, okay, admittedly, because this is an index out of bounds error. There is no element at 0. But you know what? Look what the worksheet says. I saw it before I flipped over. Assume that the array contains at least one element. So, ha! I don't want to see any snarky comments about how there's a bug in here, because it says you can assume there's at least one element, all right? So I did assume that. Now, what if you didn't want to? What if you want to go extra credit, right? So what I would do probably is I could write a little bit of code here. If the length of the array is 0, then I could return some dummy value like this, right? And then it would save me a whole bunch of trouble. Okay, but we don't need this, right? Because it tells us to assume that we're good, all right? So I could print this now. I could print max value on data, right? Max value of data, and I should get 9, right? Let's see if 9 prints out at the bottom, and it does. This algorithm works. Why was a for each loop appropriate for this? Well, I only needed to read the values of the array. I didn't need to change any of the values in the array, right? Nor did I need to see 2 values in the array simultaneously by index, okay? So a for each loop, is really good for finding the max value, or for finding a minimum value, or for finding if something is in an array, right? Okay. My computer's kind of freaking out a little bit because we're recording. Let's see what we can do. See how much further we can get. Write a method called average that computes the average of all the elements in the array of integers. It returns the answer as a double. Okay, because we know that like the average of 2 numbers could possibly be decimally. Like the average of 4 and 5 is 4.5, for example. So, okay, I get it. We know how to find the average of numbers in life, right? Let's write the algorithm. It is public static int. No, it's a double. I'm returning a double. Average for some int array. Pardon me. Okay, the way you do it is you sum them up and you divide by the number. Okay, so we're going to need a variable that contains the sum. Now, before I've added anything, I assume the sum is 0. Then I can use a for each loop. For every int I'll call num within my array, I could just add that on to the sum. Sum plus equals num. Right? So the sum would be 0, and then it would add on the first element, and then the sum would grow, and the sum would grow even further with the next element until it got all the elements summed in, and then the sum would represent the sum of all the elements at this point. And then I simply want to return, I need to cast a double here. Double sum divided by the length of the array. Right? Was that too insane? I don't think so. If I didn't cast a double, then I don't get a double as an answer, right? When you divide an int by another int, you get this weird int division that Java does. Like 10 divided by 6, for example, is 1 in Java. But 10 divided by 6, if you cast the numerator or denominator to double, will give you the proper answer, which would be like 1.66666. 10 divided by 6, for example. Okay. That's it. Let's see if it averages. Let's make a new array. Let's dump this data. Let's actually make data something that we can visualize the the average for. See what I mean? So I'm hoping that this comes back as 4.5. Let's print the average of this. Okay, good. This is going to work. So if I add like on 100, the average should go up. That's 109 divided by 3. That's like 16.3333 or something like that. No, 36 point something like that. Yeah, like that. There we go. So this is working. It's checking all the boxes. This will even work if the array is empty. So how do you make an empty array? You're like, wait a minute, you talked about an empty array. That's how you make an empty array. So the average of this one would be man, not a number. Kind of fun. Okay. Here we go. Next. Okay, doing all right. Exercise 2. Write code that creates an array double the length of the array numbers from problem 1b. Okay, so let's say we had, I know I erased that earlier. So let's say we had some array called numbers, and we were super excited about it. Right? Some array called numbers. I don't even care how long it is, because my new array, new one, I could make a new array that's double the size just like this. It's a new int array, and it's whatever numbers.length is, the numbers.length times 2. It would simply just figure out the length of this one, double it, and then it would make a new array. So this has 1, 2, 3, 4, 5, 6 elements. This one would simply have 6 times 2 elements in it. So if we were to model this right now, it's essentially a bunch of zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? At this line of code, it does fill the array with zeros. Okay, that's the default value for an integer array. Okay. Write code that copies the numbers array from index 0 to 3 into your new array. Okay, well, I'm going to need, so do you see this? I'm going to need indexes. Okay, so this is a huge hint. Some of you in your classes around the world may be wondering, do I use a for each loop? Do I use a for loop? Ask yourself, are you going to need the index? That's one huge indicator that you need the old school for loop. Or maybe if you need to change the values in one of the arrays, then you need an old school for loop. The for each loop is good at reading values, not at changing values though. So here's what I'm going to do. I'm going to write code that copies. So for int I is 0, from 0 to 3, right? So 0, I is less than or equal to 3, right? And then I can just say, hey, my new one array at that particular index, I want you to get your value from the numbers at that same index, right? So I'm just going to copy the 3, 3, and 0 over. Oh, wait, no, the 4, 7, and the 2 over, all right? So I should have the 4, 7, and the 2. Let's test it. 0 to 3, I'm tripping because I forgot that index 3 is right here. 0, 1, 2, 3. There you go. Yeah, that's 4 elements. Come on, man. Fleischman. There you go. So yeah, that worked. 0, 1, 2, 3. Yep, okay. Moving on. Generate code that sets every element in numbers to 42. All right, we can do that, right? Let's write that code right now. If you're going to set the elements, you're going to change the elements. You're going to change the elements. You cannot use the short for loop. You got to use the old school for loop, right? I can prove it to you. I can try. Watch this. I'm going to try to do the other one. For int num within the numbers array, I want num to be 42, right? And I could print numbers down here and show you, right? Look what happens. Nothing. I told you. Right, check it out. 4, 7, 2, 5, and nothing changed. Why? Well, here's the deal. This little variable num is like a little local copy, right? Num is like a little local copy. So at first it's 4, right? But it's not this 4. It just borrowed the value, right? It's a copy of that 4. And then it goes, all right, so it's 4 at first, but now I'm changing my mind. It's 42. But notice what changed to 42. Just this little local copy. Not the value in the array, that stayed the same. So using a for each loop does not change the values. How does this change when I go to a regular for loop? If I want to change all the values in in an array. I have to go numbers.length and go I++. I want to go through every index. Now here's the deal. Using indexes is a way for you to actually access the values up here, not just copy them here, but actually access the values in the array, right? And actually change them up there, not just locally, okay? So if I wanted to say numbers at I equals 42, now notice numbers at I isn't just a little local copy. It really is changing this value to 42, and so on for the next element and the next until the end. It's way different than a for each loop. This actually gives you VIP access to change the elements here, not just read from them, right? It's not a read only. Right? So now if we do this, they all turn into 42s, okay? Let's move on. Okay, let's go. Mr. Hardesto's computer class grade goes as follows. This is the big one, okay? 25% daily assignments, 35% labs and projects, 40% on tests. Make 3 arrays of doubles, each representing the grades for the assignment in each of the 3 categories. So homework grades like so. So there must have been 4 assignments. The student got a 92%, 40%, 100, and then a 93. So there's not very many homework assignments. Then we're going to write a passing grade method, which takes the 3 arrays of doubles, 1 for each category, and returns whether or not the student passes the class. Okay, this would be challenging because each of these grades has a weight attached to it. So even if you do really well on your homework, that only counts for 25%. I guess daily assignments would be, I don't know, would be that one, right? So the weight matters. So each of the averages is going to be weighted, okay? So this takes a little bit of math know-how. So if you haven't had like an algebra or an algebra 2 course, this is probably going to seem pretty kind of foreign to you. But here's what you can do, right? You can go to, I know some people think Google is evil. I've just submitted to the evil. So calculator, calculate a weighted average, right? Just Google that, and you can kind of watch the math formula. You can, if you want more deep math understanding of calculating a weighted average, go Google something, and I'll kind of just, once you pause and kind of catch up on the math, come back when you understand it. Because I also happen to be a math teacher, so this makes sense to me. All right, I have all this extra code that I don't think I'm going to need anymore, so I'm just going to dump it. Let's just dump this stuff and then start over, okay? All right, so I was told to make 3 double arrays, right? So like daily grades, right? Let's just do like, I don't know, 0.90, 0.87, 0.98. Oh, you know what? Java doesn't like that. All right, let's say that this student that did really well on their homework, 90, 87, or their daily work, right? I'm going to kind of be really lazy here for the sake of time, and you can do the same if you want. The test grade will be like this. I'll change some of these, right? So like maybe some of the tests didn't go so well. I know a lot of students that happens to. Daily, test, and then like projects, right? Is that what the other one was? Sorry. It's dailies, labs, and tests. Okay, yeah, there you go. Labs. Let's say that this student did like okay on the labs. 45% on one lab, 87%, and then like 89%. And you know what? I could even make, maybe there was a lot more homework. So check this out. I'm just going to do this. It doesn't mean, like, it doesn't matter that these arrays are different sizes, right? It shouldn't matter. Oftentimes you'll have a lot more labs than you will homeworks and tests or whatever, or vice versa. These arrays don't need to be the same size, right? So it's really important to know that. Okay, moving on. Did we miss, I feel like we missed a question. Huh. No, I don't think we did. Moving on, write a method called passing grade, which takes 3 arrays of doubles, 1 for each category, and returns whether or not, okay, so I need to make this method, it says returns whether or not. returns whether or not sounds like a Boolean to me. True or false, whether or not. Public static Boolean passing grade. I'll just call it passing. And it's going to take 3 arrays of doubles. Double array for the daily, a double array for the tests, and a double array for the labs. All right, so I don't typically like doing this. I do not like naming my parameters just D, T, and L, but I wanted to make sure that you know that there are some people out there in my class and around the world that still think that these have to match these. They do not, right? When you pass these arrays in here, they don't have to match the original name. It's another variable, right? It's another variable pointing to the same array, okay? All right, so what I would like to do to calculate the weighted average is, if I were to find, so I want to find the averages of each category first. Then, weight the averages. And sum them. And then I want to return whether that sum breaks the threshold of 60%. Okay, so what's really going to be helpful is I need to find an average of all these arrays. I don't want to write that logic 3 times, so I'm going to recognize this opportunity to write a method that calculates the average. Public static double, it returns a double, an average. And it's going to take an array of doubles. Okay, so this is just going to take each of these like daily assignments, the tests, and the labs, and average them out. And we actually already did this algorithm, so I don't want to belabor it. If you need to go over how to do this again, go back to a couple minutes ago in the video and find it that way. It's the same exact algorithm. And then we can return the sum divided by the length of the array. And the fact that these are already doubles means that we don't have to cast anything, right? So this average method is going to really help us in finding the averages of each category first. So for example, like daily average is just a result of the call average on the array D, right? The array D can go in here, and then it'll calculate the average of that, store it as daily average. And it's going to be remarkably similar for the other two, right? So the test average, for example, will be the average of the T, and the lab average will be the average of L. There you go. Right? This is yelling at us because we haven't yet returned anything. Don't worry about it. So we need to weight the averages and sum them. So I guess I'll say weighted sum. So this is a double. So I need to go back and look at those weights. Excuse me. Whoa. 25% for the daily assignments. So it would go like this. If you looked up that Google, like 25% times the daily average, plus 35% times the labs and projects, 0.35 times the labs and lab average, plus 40% of the tests, right? So 0.40 times the tests average. All right, so that's our weighted sum. This is how you calculate a weighted average. So you find each of these averages, attach the weights to them, and sum them up, and that's like the final grade in the class. So what I would do is I want to return whether or not this weighted sum is greater than or equal to 0.60. Okay, we could have done that in a slightly different way, but this is a fairly decent and readable algorithm, right? Store the averages, calculate the weighted sum, and then return whether that weighted sum breaks the threshold, right? So what do you think about this student, for example? Let's test this. Weight is passing. I need to pass in the D, the T, then the L. So it's going to be, I got to pass in the daily, then the test, then the labs. All right, I think this student passes the class, so it should return true. And it does. So let's make them bomb a bunch of tests. Like let's say they got 0 on all these tests. Let's just make sure that they fail. It's kind of cruel, but let's do it anyway. So let's take out a bunch of these and 0 here and 0, 0 here. There's no way that this student passes, right? Okay, they fail. This appears to be working correctly. I'm confident that this works. Okay, you could probably fudge around with it and make it cooler or something, but it works. Okay, go back and slow the video down if you need to. We only have one more left, I think. Write a method called mode that returns the most frequently occurring element of an array of integers. Assume that the array has at least one element and that every element in the array has a value of, ooh, that really helps. Assume that at least one element and every element in the array has a value of 0 and 100 inclusive. This is super helpful. If you want to do the challenge problem later, that's harder. Harder is the wrong word. That is, you got to think more algorithmically for that one, okay? So here's the thing. If I know that the values are between 0 and 100, I could make a loop that goes from 0 to 100 and then look through the array and see how many zeros I get, how many ones I get, how many 2s I get, how many 3s I get, how many 4s I get. And I can kind of keep track of which of those counts is the greatest as I go. So by the time I get to 100, one of those numbers will have occurred the most, right? So let's look. Let's do the non-challenge way first. Okay, the mode of an array. Public static int mode. It's going to take some array, right? Now what I'm going to do is loop through the numbers 0 through 100. 0 through 100. Count how many times they occur. Right, so I'm going to assume, right? Remember the dating analogy? I'm going to assume before I loop through that the mode number is 0, and the number of times that I've seen it. Well, let's assume that I've seen it no times at all, right? Yeah, so I haven't actually seen a 0, but I need some numbers here to compare stuff to, right? The number of times I've seen a 0 is 0. I need to kind of start out with some values. So what I want to do is I want to loop through the numbers 1 through 100. Right? So 0 from 0 to 100, sorry. And less than or equal to 100 would be fine, I++. And then within each number, so right away, for example, like I is 0, right? And I want to count how many times, how many zeros are in here. How many zeros are in the array, right? So I would go like this. I would look through this array for every number within my array. If that number is 0, if that number is equal to 0, which it's really just I that I'm looking for, right? I want to look for zeros first, then I want to look for ones, then I want to look for 2s. So really I want to compare it to I. If that number matches I, then I want to the number of local, so this is a mode occurrences actually. So let's do this. This is the number of times I've seen the mode. This is like the winner, like the most I've ever seen. I should also have a little local variable called I occurrences. Now this is how many times I've seen 0, how many times I've seen 1. And I count that, right? I want I occurrences to go up here. Sorry, I'm going really fast, you guys. I'm really sorry. The day's kind of coming to a close here. And I'm explaining things quickly, but hopefully because it's a video, you can go back and kind of think about it, pause it, and then find some time to comment and ask me a question. Let me kind of try to re-explain myself because I added some variables and I changed some stuff. I'm going to assume the mode is 0, and how many times did I see that mode? None. Basically, in here, I need to count how many times I see each of the numbers 0 through 100 in my array, right? So I need to say, I need a little local copy in here that says, how many times have I seen 0? How many times have I seen 1? How many times have I seen 2? How many times have I seen 3? And if that number ever beats the mode occurrences, well, then we have a new mode. Does that make sense? So if I find that number, I change the I occurrences by 1. Starts at 0, pardon me. Getting scrambled here, I need some coffee. I start out not seeing any, and then if I find one of them, I change it by 1. For every number in the array, if the number matches the number we're out here, I've seen that number one more time than before, okay? So like for example, right? So I will be 0 at first. And then it'll look through the array. How many zeros do I see? I see just 1 0, right? Then I can compare that number of occurrences to what I think is the leader out here. And if it beats it, then I have a new mode. I hope that's explanation enough. All right? Right here, after I'm done looking through the array and counting the number of occurrences of I can check to see, is it the new mode? Is I the new mode? Right? So here's the deal. If I occurrences is greater than the mode occurrences, which what I thought was the mode, right? Then I have a new mode. Then mode needs to be I, and then the mode occurrences has now been overthrown as well by the I occurrences. Okay? And these are spelled wrong, so that's sweet. I'm not a spelling guy. Okay, there we go. Then I go to the next number and the next number until I find the mode. By the end of all of this, by the end of this for loop, right, look at where this ends. This goes through the number 0 through 100, and I know those are all the numbers possible in my array. And by this point, I can return mode. Okay, I loop through the numbers 0 through 100 and count how many times they occur. Right, so I go from 0 to 100. I haven't seen this number yet. I look through the array. If I find it, I change I occurrences by 1, go up by 1. I'll keep looking through the array. If I find more of them, I keep changing that. And then I say, is that the most common number I've ever seen in my life? Is I occurrences greater than the mode occurrences? Well, if so, then I've just found a new mode. Mode, you are now I, and mode occurrences, you are now I occurrences. And I go back through and do it over and over again until I finally have the mode. All right. That should be an ample solution for that one. Okay, this video is getting quite long, so let's finish it with the challenge real quick. Okay, the challenge is to write a version of this method that does not rely on the values being between 0 and 100. Okay, so we can't do this tricky mode where we go from 0 to 100 because we can't loop through every integer. We shouldn't anyway. So let's do this. Public static int mode challenge for an int array. It's going to be very similar though. So here's the deal. Let's make an array up here like 1, 5 through 6, 8, 9, something like this. And let's double some of them up. 2, 5, 6, 1, 1, 3, 4, 3, 3. Okay, I don't know. Something like that. So I can't guarantee that these numbers are between 0 and 100. This is just something to visualize. So what I'm going to do is assume I need to go through every element in my array. Right? For every element, so actually, you know what I need to do? I need to have those same, so the mode I'm going to assume that it's the first element in the array. And I'm going to assume the number of times mode occurrences. Actually, I've seen none of them or one of them. That's kind of inconsequential. Let's say I haven't seen it yet, or let's say I've seen one of them, right? Because if it's in the array, I've seen one of them. That's fine, okay? I've seen one of them so far, and I'll actually find that there are more of these. Just hang in there with me. You'll see. Check it out. Okay, so I need some leaders to start so that I can compare things to it. So 1 will actually beat itself. This isn't even actually true. So let's do this. For every number within my array, I'm going to count how many times I've seen this number, num count. The occurrences is kind of weird. Why don't we just do mode count? That's actually easier, right? It's easier to spell. So mode count, there's one of these. Num count, I haven't seen this number yet, but when I go into another for each loop, so here's what I'm going to do. Right now, num is this. And what I want to do is start counting how many of these there are, how many ones there are. So what I can do is just hold the blue thing right there. That'll be the outer for loop sitting there, right? I can run another loop, that'll be my mouse, and I can start counting them. So I'm going to hold this right here. So the num I'm looking for is 1. How many do I see? I see 1 so far. 2, 3. Cool, so I've seen 3 of them, right? Then that would be my new mode. And then the outer for loop would go over and move over to 5, and I would do the same thing. Is this a 5? Nope. This is a 5. So I could count each of these with a nested for loop. So this other one, some number, other num within the array. I'm using a for each loop because I don't need to change these values. I don't need the index or anything. Right? So for every other num in the array, if my other num is the same as my num, then I want to make my num count go up by 1. Like, even just looking at this, like, I'm just kind of scramble-brained by the amount of coding I've done today. So I don't know if it's like one of these things, but the word num looks really weird to me now. Okay, num, if this, like, remember how, like, at first this outer for loop is going to be here, right? Num will be 1. Num count will be 0. I haven't seen any yet until I go in here and I rip through the array again with my mouse. While the blue thing sits here, I found one of these, 2, 3 of these, right? So totally of 3 of these. So after I'm done counting these, what I can do is I can say if this num count is greater than the mode count, I have found a new mode. Mode, you're really just num. And mode count, you should be num count. We have a new leader. Right? And by the end of this, I should have the mode. I don't see what's wrong with this. I think this is very, very similar so I can return mode. Now here's the interesting thing. I used for each loops here, and I used for each loops, but I used a for loop here because I needed to go from 0 to 100. That makes sense. Okay. Let's actually test this to make sure it works. This array right here, let's try to make it. Let's make this array. Numbers, and it's not going to like that syntax. It's not going to like that syntax. What does it think the mode of numbers is? One. False comes from the test. So is 1 really the mode? There are 3 of them. Is there more of anything else? I don't think so. Let's make it so, though. Well, there's 3 3s, but that's like a tie, but it had the 1 first. It found the 3 1s before it found 3 3s, so it's telling me that the mode is 1 because it found that first. But if I have just one more 3, hopefully that will find me that 3 is the mode. Okay, that seems to be working. Could I make any other number the mode? If I just added a bunch of like 6s here. Oops. That should hopefully make 6 the mode. This works. All right. So I know I kind of scrambled through it. I ripped through it really hard and really fast. Long day as a teacher. You students know what it's all about. Your brain gets a little scrambled. So hopefully you take advantage of the fact that this is a video. You can go back, you can rewind, you can comment to me, and you can email me. You can write me questions and comment. Go check out my other videos. I do write people back. I help people. So if you're really having trouble, write me a message, send me a comment. I truly will help. And if you have a cooler solution than mine, show me. I'm trying to get better too. We can help each other. Together we can do this. All right, power of code. I hope you enjoyed this video. I think that's all we have. Take it easy. Have a great weekend. And I'll talk to you soon in the near future. Happy coding, everybody.